Okay, in this video, we're talking about the vertex form of an absolute value equation. However, this entire thing can be done with our transformations that we just learned, and that's the reason it follows it up. So let's remind you of these transformations. First off, it says, this is just warm-ups. What is the parent function of an absolute value function? Now, remember that the parent function is the most basic absolute value function. That'd just be y equals absolute value of x. Now, describe how the following functions would compare with the parent function. So, a reminder, as we go inside, and if we subtract 5, things that happen inside with x, pluses or minus, happens backwards. So, a minus 5 would move your function right 5. If you were to add a 9 on the outside, now things that happened outside would move your function up and down. So a plus 9 on the outside would move it up 9. Now you don't worry about the whole forwards, backwards. It's going to do exactly what it says it's going to do. A plus 9 will move it up 9. Negatives flip. So the only question is it a horizontal or vertical? If it happens on the inside, it'll be horizontal with the x. If it happens on the outside, it'll be a vertical. So this will be a vertical flip. And when we say vertical, that would be up and down. So therefore, that would be, if you draw your xy axis, it would flip it across the x-axis. The next one, we actually have two different transformations. We're going to multiply by 3. Anytime you multiply by numbers, you're going to stretch or compress. It's on the outside. It's going to be a vertical. If it's a number bigger than 1, it's going to stretch it. If it's a number between 0 and 1, it's going to compress it. So this will be a vertical stretch. We'll even put by the factor of, or times 3. And then the minus 2 at the end, we'll move it down 2 because it's, again, if it's outside, it's going to be up and down. If it were inside, in here, it would be left and right. And then finally, E, you have two different transformations here as well. The plus 6 on the inside would move it left 6 because you always work backwards. The 1/4 in front of it, again, is a stretch compression. If it's a number between 0 and 1, it's going to be a compression. It's a vertical because it's on the outside. Vertical compression times a fourth. And the last one, you have actually 3 different transformations. On the inside, you have a plus 7, which is going to move it left 7. You have a negative out front, and negatives flip. So since it's out front, since it's not inside the function, that will be a vertical flip. And that would be across the x-axis. And then finally, the minus 2 on the outside, that would be vertical as well. It's going to move it up and down. That would move it down 2. You don't have to worry about changing the sign on that or changing the direction. Okay, so now let's actually talk about what we mean by this vertex form. Vertex form of an absolute value function looks like this, f of x. And we're going to apply all the different transformations that could happen. We might could have a number out front. X minus h on the inside is going to move it right h if it's a positive, left h if it's a negative. And then plus k would move it up k if it's a positive, down k if it's a negative. So therefore, a normal f of x equals absolute value of x. Normally, your vertex here, if you don't remember, you can take that inside stuff and set it equal to 0. Normally, your vertex for this function is 0, 0. However, this function would move your vertex to hk. So we can actually, here's what it's saying. You can actually look right here, and you can determine where your vertex is going to be simply by knowing the transformations. You don't have to set this stuff equal to 0 and solve and all that anymore. You can simply look here and here. To where also, here's another thing, A will be the slope. You could pull this number right here, and that's going to be the slope of the right side of your absolute value function. And negative A is going to be the slope of the left side. So let's try to apply some of this. So we see with our transformations, this -2 is going to move your graph right 2. This -4 is going to move your graph down 4. So right 2 and down 4, that's going to be your vertex. If there's a number out front, that's going to tell us what our slope is. Since it's a 1, then that means the right side of our absolute value function will have a slope of +1. And that means the left side of our function will have a slope of -1. So that's all we have to do now to graph these things, which is so much more easy. Let's see, left 5, and then there's nothing out here, so we're not moving up or down any. So we're just going to go left to the 5. 1, 2, 3, 4, left 5 right there. And that's our new vertex. Here is our slope. So we're going to go rise and run 3 over 1. And then you can do it again. For the left side, you're going up 3 and left 1. And you see the symmetry there as well. And there is going to be your new absolute value function. Number 3. This +1 moves your graph left 1. This -2 moves your graph down 2. So left 1, down 2 is here. 2 over 1 is your slope. So we're going to rise 2 and run 1. Or we're going to go left 1, rise 2 and left 1 to get our -2 there. And there is your function. Again, we see this is so much easier than actually doing our table of values, which we still could do. Right 6, up 0. 1, 2, 3, 4, 5, right 6 and up 0. There's the vertex. Your slope is a -1 for the right side, so we got to be careful with this. So -1 is our right side slope. +1 would be our left side slope. So what this -1 out front actually did was flip this absolute value graph over. So there's what it would look like now. So you got to be careful. If it is a minus, it will be upside down. Left 1, down 1. Put your vertex here. 2/3 is our slope. Rise 2, run 3. Rise 2, run 3. Rise 2, run -3. Rise 2, run -3. There is your parabola, or there is your absolute value graph. I keep calling it a parabola. Okay, it does not move left or right any. However, it does move up 7. So 1, 2, 3, 4, 5, 6, 7. There is your vertex. And now here's our slope, and it will be an upside down absolute value function because of the negative. So the right side will be -3, 4. So down 3 over 1, 2, 3, 4. Down 3 over 1, 2, 3, 4. The left side will be down 3 and left 1, 2, 3, 4. Down 3 and left 1, 2, 3, 4. So there is your V-shaped graph. Number 7. Again, we're dealing with some piecewise functions here. -1 is our cutoff point. So let's put a line at -1 to separate these graphs. Okay, now the left side, everything to the left of -1, we're going to graph this, 4x plus 2. Now that's just a regular linear equation, y-intercept of 2. Rise 4, run 1. Okay, at -1, we are non-inclusive. We're not going to include the point on this graph. So slope is 4, so we're going to go down 1, 2, 3, 4, and over 1. Open circle, we're not including that point. We can do it again, down 4, 1, 2, 3, 4, and over 1. That point will be included. You could do it again, but this is going to be your graph. It's going to be a line extended forever in this direction. We're not going to include this point here. We're also not going to include that point. You can now erase it. Okay, and then on the right side, we have an absolute value graph. We're moving left 3 and up 0 to get to the vertex. So 1, 2, 3, there's going to be your vertex. We have a slope of -3 on the right side. So 1, 2, 3, and 1. Still an open circle. We're still not on our graph. We are going to include the line on this part of the graph. Down 3 and over 1 gives us this. Down 3 and over 1. You could do it again to give us another point, which is going to be about right there. Then the rest of your graph is going to be over here. So open circle and so on and so forth. So we really don't need that part. So we can erase everything that's going to be out of the correct portion of the graph. And this is all we're left with. Okay, on number 7, we have a piecewise function. We have our division of -1. The first part of the graph, we're graphing on the left side of -1. Second part of our graph, we're graphing on the right side of -1. So let's go ahead and put that division line. Okay, our first part of our graph on the left side of -1, we're graphing 4x plus 2. So that's just a simple line. So 4x plus 2 has a y-intercept of 2, has a rise of 4 and a run of 1. So 1, 2, 3, 4, and 1 is going to look something like that. However, we want to graph it on the left side of the line. We're not going to include the line, so we're going to go down 1, 2, 3, and 4 and over 1. We're going to do it again and again. 1, 2, 3, 4, and over 1. So it's going to look something like that. However, that last point was included because it's going to be in the right portion. Again, we did not include the point that's on the line. So therefore, your graph will look something like this. Continues on. Let's erase the part that we don't need. Second part of your graph, I'll do it in a different color. Second part of your graph is an absolute value function. The plus 3 would move your vertex left 3, and then you have a 0. There's nothing on the end, so therefore left 3. 1, 2, 3, and up or down 0, so we're going to stay right there. And again, that's not going to be on your graph because we're only graphing from the line over on this portion. We are going to include any points that are on the line. Let's see, our slope will be a -3 over 1 for the right side, so we're going down 1, 2, 3, and over 1, still not on the graph. The left side would have a slope of +3, or you can just reflect that point over. Go down 3 and over 1 again. Now we're on the line, so that point will be included. And again, you can always just keep reflecting to get the other points. You could go down 3 and over 1 again, which would be about right in there. But that's the only points that we'll need. So that's not much of a graph down here, but it will look like that right there after you get finished. And again, you can erase now the line that you used to graph. Number 8. Again, we have another piecewise function. Our divisions in this are at -4 and +2. And the first part of your graph, your absolute value function here, you're graphing to the left of -4. So we're going to go vertex is left 1 up 5, left 1 up 1, 2, 3, 4, 5, which would be right here. And that is not going to be included because we want to graph this over here. So anything that's not in that or on the line, we are going to include the line because it's or equal to. So now my slope is -1 for the right side. So here's what the right side will look like. Here's what the left side will look like. And then once you get to the line, we are including that point and anything to this side. So we're only graphing that from here over. So there we go. So you can erase the rest of it that you graphed. The second part, we're graphing y equals 3 from -4 to 2. We're not including it, but that's going to be a horizontal line. So open circle here and open circle here at y equals 3. Simply draw your horizontal line. There we go. And then the last portion is going to be y equals -x plus 7. So you have a y-intercept of 1, 2, 3, 4, 5, 6, 7 up here. And your slope is -1 over 1, so you're not going to include either one of these points. However, at 2, you are going to include this point, and you're going to continue on. And that's what your graph for that portion will look like, starting at the line. Your graph looks something like that, and you can go back and erase these points here now, and you can erase the lines. So there's your graph. Number 9. Now we're dealing with some inequalities. We're going to shade these. So we're just showing that you can use these shortcuts that we've taught you now. We're going to go left 4, down 6. So from your origin, left 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There's your vertex now. Your slope is going to be 1 over 1. So the right side of your absolute value function will look like this. And you can just keep drawing it on. I'm going to draw it all the way over just because we are going to have to shade. The left side will have a slope that is opposite, which will be -1. So it'll look something to that effect. I didn't mess up because it's or equal to. I should have addressed that before. So we're going to do a solid line. Since it is less than, from every point, we're going to shade below each of these points that are on here. So we're shading this side. So there is your graph. Anything that is on the line or on this side of the line will be a solution to that inequality. Next one, we got it flipped upside down because of the -2. To get our vertex, we're going to go right 5, the opposite of -5, and we're going to go up 4. So we're going to go 1, 2, 3, 4, 5, 1, 2, 3, 4. The right side of my graph will have a slope of -2, so it'll have a dot here, a dot here, and a dot here. The left side of my graph will have a slope of +2, which you can just mirror that side to get these dots over here. Since it is greater than, that's going to be a dotted line or a dashed line. So let's do that first. And since it is greater than, we are also going to shade above. So from any point, figure out which way above is, and we're going to shade on this side of my graph.